This is 2.3, day 2, part 1. This first slide, don't write down. It's just talking about what is your remainder theorem. If you use synthetic division or long division and your remainder is 0, then it is a factor of the function. And you can write it in this form, where this is your factor. That's what you're left with, and then that is your R. If you get a remainder, you can also write it as an ordered pair. So let's say you get a remainder of 5. That would be a point on the graph at whatever you evaluated, and then 5. Next example, don't write down. You'll just watch and help me. So we're going to use synthetic division to divide this polynomial. So what is going to be my k of this polynomial? Yep. You always take the opposite of this. So my k is -2 that I'm dividing out. You want to make sure you have your all your terms. If you don't have a term, let's say there's a missing term x, and then you put a 0 in. So we have coefficient of 1, 5, 5, and then -2. What do you do with the first spot? What do you do with the 1? Bring it down. Now we multiply. -2 times 1, -2. Then we add. 5 plus -2 is 3. And we multiply. -2 times 3 is -6. Then we add. 5 plus -6 is -1. Then multiply. -2 times -1 is 2. Then we add the column, and we get 0. So what is our remainder here? None, it's 0, so this is a factor of the polynomial. So remember, we decrease if it's a third degree polynomial. When we take out that x plus 2, where this is now your x squared term, your x term, and your constant. So the remainder tells me that I'm going to have an x-intercept at -2. So I have an ordered pair at -2, 0. That's an x-intercept. That's a 0 of the function. If I wanted to rewrite it in factored form, I would use this resulting x squared x in constant and continue factoring, or using synthetic division. And that's what we're going to do today. So I took out the x plus 2. I'm left with 1x squared plus 3x minus 1. You could continue factoring this quadratic to find the next two x-intercepts or zeros of the function. This is a new problem. I would recommend that you write this one down. So use synthetic division to find F3. So now we're going to use synthetic division to find points on the graph. In this case, we're going to find 1 point. Our x value is 3. We're dividing out x minus 3. So if they ask you in your homework to evaluate the function for f of something, you can use synthetic division to do that. Whatever your remainder is the value for that evaluation. How many zeros should I have? 4, because of the fourth degree polynomial. So I set up my synthetic. 2, 0, -15, 10, and 5. Why do I have a 0 in that setup of synthetic division? There is no x cubed here. You have to be careful that when you do synthetic division, you have placeholders for every term from the highest degree, 4, down to its constant. Now we're set to do synthetic division. Yes, sir? Is it negative 10? Oh, thank you, negative 10. Good job. All right. So the first step with synthetic division is to bring down that first value. So you bring down the 2. Now we multiply. 2 times 3 is 6. That's going to go right there. Now remember, we always add the columns. So 0 plus 6 is 6. Now we multiply. 3 times 6 is 18. Then we add the column. Negative 15 plus 18 is 3. Then we multiply. 3 times 3 is 9. Add the column. Negative 10 plus 9 is negative 1. Then we multiply. 3 times negative 1 is negative 3. Then add a column. Did we get a remainder? Yes. What is the value of our remainder? 2. So we know that x minus 3 is not factorable by that quartic function, but it can tell us the ordered pair. F of 3 equals 2. F of 3 equals whatever that remainder is. So what would be the ordered pair then on the graph? 3, 2. So if I were to graph out this quartic function, remember quartic shapes are W's or M's depending on its leading coefficient. If we graphed this out, it's not an x-intercept, but it is a point on the graph. So that's how we can also use synthetic division. What's the equation?
No, yeah, like
the factored form?
Yeah, the factored.
Yep. So if you wanted to write it, like let's say they ask you to write it in this form, you have your factor, what you're taking out, what's left, and then your plus r. So we'll go back and do that. They didn't ask for it in this problem, they just asked you to evaluate it. But if you want to, you always drop down by 1. So now that's going to be your x cubed term, your x squared term, your x term, your constant, and then your remainder. So if we were to have it in factored form, what we took out was the x minus 3, and then what we're left with is 2x cubed plus 6x squared plus 3x minus 1. And then we have the remainder. So like I said, some textbooks just put plus 2. Some textbooks do plus 2 over whatever you factored out. Yes, sir.
You accept the other ones.
Yep. I'm going to stop the recording there. We'll pick back up with this again.